Welcome back to the Brain Mission channel, and we're still on the topic of the primary exit profile or PEP. And today we will be looking at how we can prepare the grade 6 children for the mathematics performance task that is slated for sometime in March. I'm thinking about in the next 2 weeks or so. So let's jump right in. Again, the time is 1 hour and 30 minutes, and you're not supposed to open until you're told to do so. All right, so please remember to follow instructions. All right, parents, we can help our kids to remember that, right? The task has 3 parts, 1 to 3, right? Part 1 has 1, 2, 3 questions. Part 2 has 4A and 4B. Part 3 has questions 5A and 5A, 5B, and 5C. So we're going to read the information in each part carefully, use the information provided to answer all questions in each part. All right, so the title of our performance task is Premium Packaging. And it reads, Premium Packaging makes cardboard boxes of different sizes. Other companies buy these cardboard boxes from Premium Packages to package their own products. So Premium Packages sells 2 types of boxes. You have 1, standard cardboard boxes. These boxes are already made. The dimensions of these boxes cannot be changed. Then you have 2, custom-made cardboard boxes. These boxes are made based on dimensions given to the company by the customers. So we have a standard and we have a custom-made, all right? 2 boxes. So I see here the name of a company. Play-Go is a company that makes and sells toy building blocks. They want to buy cardboard boxes from Premium Packaging to package their building blocks. So Play-Go wants to determine whether buying a standard cardboard box or buying a custom-made cardboard box would be better. Okay, so we're gonna help them now, right? All right, so Play-Go needs your help too. 1. Find the number of building blocks that can fit into a standard cardboard box. 2. Determine the dimensions of a custom-made cardboard box. And 3. Recommend which of the 2 boxes would be better to use to package the building blocks. Again, we have our task set out for us, right guys? So let's jump in. Here is part 1. So we're looking at part 1 and the standard cardboard box. So the standard cardboard box is shown below. The faces of the box are labeled A to E. So we have A, B, C, D, E, right? Now, the standard cardboard box has the following dimensions. It has a length of 10 units, a width of 3 units, and a height of 2 units. Okay, so this is the box standing up, right? Now, for the question here for the box is the net of the standard cardboard box is shown below. Use the dimensions given to correctly label the sides of the net. Write the correct measurement in the spaces provided. So when you hear net, what comes to mind? So it means that it would be everything in consideration. So the box here is not actually flattened. It's just a box. It's okay, you can put things in it. This illustration of the box is really, it's the same box, but now it's flattened, like you're opening the box so you can see the entire, you can see everything, or you can actually measure all the sides of the box, right? So it's actually flattened here and it's upright here. All right, so also put into consideration that we need to look for the length, width, and height. And normally if we're looking for length, we normally look for the longer sides, for the width, shorter sides. The height would be from the ground up for height. So let's, and I've already put the answers in for you, by the way, but let me explain how I got the answers, right? So for, this is a rectangular box. So it has 2 long sides and 2 short sides, right? And these sides, these things that you're seeing here is just to show the height. Like when you unfold these 2 sides here, to the height of those, right? So that's why they're like this. Cool. Now, how did I get the length? remember that the long side would be the length. So that's why it's 10 here, right? Now for the width, it's gonna be the shorter side, right? And as you can see, it's showing the width side here, right? And then for the height, it would be from the ground up. So this definitely would be the height. So these are the answers for this part of it, right? Cool. And it says, please note the dotted lines in the diagram of the net shows where the cardboard box is folded. Right, so that's how you fold. If you fold it up, it's gonna stand up like this. You unfold it, it's flattened. All right, cool. All right, so let's move to question 2. So for question 2, what we're gonna do is to try to find the total area of the amount of cardboard needed to make the box. All right, so how do we do that? We're going to use this illustration to help us. So the table 1 shows the length, width, and area of each face of the standard cardboard box. Complete the table by writing in the missing length, width, and or area of each face of the standard cardboard box. Use the net in each one to help you, all right? Or use, the net in question 1 to help you. So this again is the net. We're going to use this to help us solve this. So as you can see, there's some missing numbers here. And just to let you understand the concept around this, it says we're really trying to find all the different areas of the different section of the box, and we're going to add them all together, and that will give us the total area that we need to create a cardboard box of this dimension. All right, that's all we're doing. So table 1, dimension of the faces of the standard cardboard box. So you have the face, the length of the face in units, the width of the face in unit, and the area of the face in units. So first you have the faces here. You have A, B, C, D, E, F. A, B, C, D, E, no F. And you have A, B, C, D, E up here as well. So we're gonna have to find the area of the faces by putting in the numbers that's needed. All right, so the first one is done for us. A, as you can see, it's 10 times 3 equals 30. Now how did we get that? So the length for A here is A, so it's gonna be 10. This is the length, 10, and the width is 3, so it's 10 threes, and that's how we got 30. Now B, how do we find B? B would be this one. So it's gonna be length, which is 3, and the width is 2. So it should be 3 times 2. So we're gonna put a 2 right here. Right? Equals 6. For C, same thing. C, length, well, this is the height this time, remember? But it's length times width. That's the same. So it's 3 times 2 again. So C is 3 times 2, 3. Three times 2. And that will be 6. And then D is right here. D is 10 times 3 for the width. Or 2 this time, I'm sorry. This time is 2. So, because it's the height that we're looking at, so it's 10 times 2, which is this one. So, it should be 10 times 2 equal 20. And E is 10 times 2 again. All right, and then we're gonna add all the areas here. So it's 40 and 30, that's 70, and 12, that's 82. So the answer is 82 units squared. Okay. Alright, so we're moving on to question 3, where a toy building block is 1 unit long, 1 unit wide, and 1 unit high. And the question reads, how many of these blocks can fit in the standard cardboard box? So all this is asking you to do is to find the volume. So volume is just length times width times height. So that should be 10 times 3 times 2, which should equivalent to 60. Alright, and I think 60 of these blocks can hold in the box. But I've already written up the answer for that, just for the interest of time. I try not to make these videos too long, guys. Right, so here it is. So to write an answer, it would be to get the amount of blocks that can hold in the box, we need to find the volume. Volume is length times width times height. So that would be 10 times 3 times 2. Answer would be 60 blocks. Now this page is left blank. Let me remove this. So this page is left blank. We're just gonna scroll past and we're gonna move to this one. So for this one, we're now in part 2 and we're talking about the custom-made cardboard box. So Plego is thinking about ordering a custom-made box. The total area of the net is used to calculate the amount of cardboard needed to make the box. Plego has asked Premium Packaging to design a custom-made box that meets the following requirements. So what's happening here now? We're actually being asked to create or make a custom cardboard box. So this is where it really, you need to pay attention now. So the dimensions or the criteria is it must be different from the dimensions of the standard box. So we can't use the same dimension. And when we say dimension, what we're talking about is this dimension here, where it's 10 by 3 by 2. We can't do that. We need to create our own or a custom, but it also said it must hold the same number of toy building blocks as the standard box. So although it is of a different dimension, it should hold the same amount, which is 60, right? 60 blocks. So although we're changing its form, it should still hold 60 blocks. And its height, so its width must be more than 2 units, right? And its height must be 2 or 3 units. So all you need to do to ace this one is to ensure that you get the same volume that is 60 but using a different equation. So what I did was to ensure that I followed instructions. The height must be 2 or 3, so I left the height as 2. The width must be more than 2 units. I made the width 5. And it didn't say anything about the length, so I just decided that I can just choose a number for the length. So I chose 6. Why I chose these numbers? Because if I remember that volume is length times width times height. So all I need to do is to find numbers that can, when multiplied together, it will give me a volume of 60. Now, if the length is 6, width is 5, and the height is 2, 6 times 5, 30, and 2, 60. So here I have some numbers that can give me a different dimension from this one, right? And gave me the same 60 volume as the standard box, and that's what you need to do. Okay? All right. Now we have our dimensions. But now let's move on to B, which is asking us, how much cardboard is needed to make the custom-made cardboard box, and show your work in the space provided below. Now this seems like it's challenging, right? But no, it's not, guys. Think about it. All this is asking us to do is to do the same thing as this. So remember how we found the dimension of the faces of the standard cardboard box? We just need to do the same thing for this using the dimensions that we have created, right? So all we need to do is to just do a table just like this, all right? Now I've gone ahead and created a table just for the interest, so we don't spend forever on this video. So I'm just gonna yank it over real quick. All right, so I created a dimension. So remember that I would have been using the same dimension that I created for the custom, which is this here. The length is 6, width 5, and the height is 2, right? So from here now, I'm just gonna do the same thing. You would have A, B, C, D, E, right? So that's why I would have the A, B, C, D, E just the same. But then I would have to match these up and not the ones that I was doing here, because this would be for the standard, remember? So you'd have to now put your own area. You're gonna have to find the area for each aspect of the box, right? So remember, you're working with the length is 6, width 5, height 2. So let's show how we'll do this now, right? So the first one would be A, which would be here, right? So we're gonna, A would be the first face, and that would be length times width. So the length is 6, width is 5. So that's why I have the length 6 here, width 5. So that will give you an area for the first one of 30. Now for B, B would be the width. So B would be the side here, right? And how do you get the area of the width again? So remember that the width would be 5. Remember, your width is 5. So what you do, it would be 5 times 2, because it's the height. So it's 5 times 2, and that would give you 10. For C, it would be the same thing, 5 times 2, because C would be another width, right? Remember, B is this, C is this, so it would be 5 times 2 and 5 times 2 for both. So that's why you'll get both 10s here, right? Then D would be the tool length again. So that would be now 6 again times this times the height, right? Which is 2. So that's 6 times 2, 12. And E 6 times 2 is 12. So the total area for the cardboard needed would be 74 units square, right? So you would do all the working out in this box, and then you would come to a conclusion that the answer is 74 units square. I'm just gonna go ahead and write that in there real quick, 74 units square. But please remember to work out the answers, right? So the person's marking your paper can see that you know what you're doing, right? So you'll have to do the table just like this, and then put your answer at the end, right? Now for the grand finale. So we're down to the wire, guys. So we're at the recommendations stage, and let's see how we can complete this. I've already done put the answers in for you already, but as usual, I'm gonna show you how I got the answers. All right. So the recommendation is premium packaging sells both the standard cardboard boxes and the custom-made cardboard boxes based on the amount of cardboard used to make the box. So the cardboard is sold for $5 per square unit, right? Square. And the question is, what is the cost to make the standard cardboard box and the custom-made cardboard box? Show your work in the spaces provided below. Alright, so this is pretty much easy because we would have done all the work. So remember that the standard cardboard box would have already worked out what's the total cardboard that's used, which is 82 units square. So we have that already. And then we know that it's $5 for per unit square, right? As it said here. So all we need to do is to multiply the $5 or multiply the 82 by 5 to get the total amount, right? So ensure you write your answers so it's clear Okay, I think I made a blunder here though. It should be cost of. So what I have here is to get the cost of the standard cardboard box, we multiply the total area of the cost per unit square. So we're going to multiply the total area by the cost, right, per unit square. So it's going to be 82 unit square multiplied by 5. So the cost to make the standard box is $410. And same thing for the custom made, but this time remember that we would have already worked out that it's 74 units square for it. So this time it's 74 times 5, and that would be $370. All right. So based on all your calculations, which of the two boxes would you recommend that Play-Go use to package their toy building blocks? Tick the box beside the answer you have chosen. Right, so before I tick, guys, this should be clear. Remember that what Play-Go wanted to do was to get a box that can bring the 60 blocks in it but cost less. So it's clear the custom made box that we created it costs $370 and the standard is $410. So which one will you use? It must be the custom. All right, so let's go ahead and make our selection. I think we click on here and do a check mark, and we're gonna mark that it's a custom, right? Right, let's go back here and yeah, let's just use this one. All right, and then let's move forward. So you're gonna give an explanation for the type box you selected in your answer for question 5B. Now, always try to make your answer specific and clear and why you actually gave that answer. So here is a recommended answer you can give. I recommend the custom cardboard box. Here I go again, making a mistake. So this should be box, guys. So I recommend the custom cardboard box because it will hold all 60 blocks, but cost $40 less than the standard cardboard box. So that should be it, guys, and we have come to the end of another, I would say, challenging task. Now we're really seeing what's happening with PEP, guys. So guess what? We need to practice, practice, practice. And let me know in the comments what you want me to do next, or what you want me to change, or anything, guys. Just be very vocal in there, right? I want to thank you again, and remember to like, share, subscribe, leave a comment. Let me know what's happening, all right? Thanks again for being a part of this, guys. See you soon.